Hey kids, welcome to another math video. This is Module 4, Lesson 10, Eureka Math, Grade 5. It's going to be a long one, so hang in there, get your pencil ready and take some notes. Very important stuff. So our objective today is to compare and evaluate expressions with parentheses. Now, you might think, oh, okay, I can totally do this, but there's a lot more to it, so let's go through the notes and let me explain. PEMDAS. This is something that you'll hear people say, math people, who you're trying to remember the order of operations when you have a whole bunch of them in an expression. And now when it's set up with just the numbers and without any words, it can be really confusing because you can't really make sense of it and you're like, well, I don't know, how should I do this first? This is like a list of directions. Follow it in this order. Step 1, Step 2, Step 3, Step 4, Step 5, Step 6. Except the only thing that I want to kind of point out to you is that multiplication and division have essentially the same strength or like the same weight. They have the same power. And so then what you do is you have a whole bunch of, if you have multiplication and division in the same expression, you will then solve left to right, like you're reading a book, okay? Same with addition and subtraction. They both are kind of weaker than the multiplication and division as far as operations go. So you would solve them from left to right all the way across your expression. Now, I have a couple of examples. So let's say I've got a 24 divided by 6 times 2. And a lot of kids will say, well, I know that 6 times 2 is 12, so I want to start there, and then I can do 24 divided by 12, and it's really easy. And I would say 6 times 2 is 12, but we're not supposed to start there. We're supposed to start on the left with the 24 divided by 6, because when you work left to right, this is the first sign in our expression. So today we're going to be solving word problems that actually kind of tell you what's going to come first, like the sum of this many times. So we'll hop into the book shortly here. Just another example of what can go wrong. You could argue with me all day, but 6 times 2 is 12 and 24 divided by 12 is 2. And I'll say, you're right, but the order that you're supposed to solve it is actually 24 divided by 6 first, which gives you 4. And then 4 times 2, which gives you 8. 8 is the correct number, okay, the correct answer. Now, with addition and subtraction, here's another example of what can go wrong. If you have 14 minus 6 times 3, so you've got a multiplication and a subtraction, you have to do the 6 times 3 first. You might say, oh, but that will give me a negative number. Now, in 5th grade, you're probably not going to see a whole lot of negative numbers, and yet this is still the answer. So you can go down below 0. You would just count down from 14 to take away 18. So you take all 14 away, then you take away 4 more. Very different from the wrong answer that some kids will say, well, let's just do 14 minus 6 first, get 8, and then do 8 times 3 for 24. That's actually wrong. And it's really wrong. That's very different from negative 4. So, couple problems here. Again, it's going to be word kind of expressions and setting things up today and noticing, okay, sum means addition. And if I'm going to take a fractional piece of something, well, are we finding the sum or are we finding the difference? So you have to really look. You've got to use your eyes and you have to use your brain. And you're going to have to first look and think about where to put the parentheses. You have to think about what comes first, and what comes first is going to be from PEMDAS in this order. No exceptions. Down at the bottom here, this is on actually another page of notes. We will also have to do word form today. So for example, 3/4 times the sum of 9 and 11. Okay, that's what's happening up here. 3/4 of the sum of 9 and 11. And so you'll have to be able to write it in words, as well as know that sum means you've got to set it up with an addition expression, and you have to get the sum first before you can take a fraction of that answer. So it's super, super important. There was also subtraction. And remember, when we use the commutative property and we move things around all over the place with addition and multiplication, because you cannot do that with subtraction. Okay, with subtraction and division, there's a very particular order. That's why the names of all the pieces are different, because you have to start with that whole. Okay, so 5 times the difference between 1/3 and 1/4. You've got to find the difference between 1/3 and 1/4 first before you multiply it by 5. Okay, so let's get that book out. And I was thinking this is going to be such a long video. I hope we can get through it very quickly. We'll be efficient, shall we? All right, write expressions to match the diagrams. Focus. Then evaluate. Focus. I'm just waiting. 8 plus 9. All right, so on your tape diagram, you've got your 8 plus 9, which you would say the sum of 8 and 9. Okay, and so we're going to mathematically write it out, but I want to talk with you about the right things to say when you're writing it so that when we have to write the word form, you'll understand. Okay, sorry, my notes are totally in the way. So the sum of 1/3 of the sum of 8 and 9. 1 piece out of 3 of the sum of 8 and 9. So I know I have this, and I need to have an expression that will match this. Then I have to evaluate it, which is a fancy way of saying solve. Okay, so let's write this out. I have 1/3. See how I have the 3 parts and I need 1. 1/3 of what? The sum of 8 and 9. So if I'm going to write that, I'm going to do 1/3 of parentheses, 8 plus 9. Very important to put the parentheses in there, because if I didn't, then technically the multiplication sign has the power, and so it would say, well, 1/3 times 8, that should come first. But I'm saying, no, no, no. Get the sum of 8 and 9 first. So we solve by adding 8 and 9, getting 17. Now this is just like the previous lessons that we've already done. 1 times 17 is 17. 3 times 1 is 3. I have an improper fraction. I can straighten it out. 3 goes into 17 5 whole times with 2 left over out of 3. Now this is the answer for here, because this, if I did this 3 times, I would get 17. Okay? So we're again breaking it apart, reading it, we're going to write it, and we're going to solve it. Okay, now how about this one? Again, I've got these 3 parts, but I don't know what the sum is. Okay? So I have this that I can find the sum of. So I have 3/5 plus 1/2. And I have to solve this first before I can multiply it. Now I don't want to do the repeated addition. I don't want to have to do this 3 times. I just want to put times 3. And then if I do that times 3, then it's like doing the repeated addition 3 times. But this lesson is combining all the things we've done so far. So look, you have to add fractions again. I hope you didn't forget how, because that goes back to module 3. So we cannot add fractions with different denominators. We have to add fractions with the same denominator. 5 times 2 is 10, so you can use tenths. Again, keep it in parentheses so that you're keeping track of your information. Just bring it down. Okay, if my other factor on the other side is my scale factor, if 5 times 2 is 10, then right below the 3/5, 2 times 3 is 6. Right below the 1/2, 5 times 1 is 5. Now I can add these because they have the same denominator, and I get 11/10. This is my new factor that I'm going to multiply by 3. Also, we learned about multiplying whole numbers in a previous lesson. So we multiply across, and multiply across, you can always or also look to cross cancel. You can move factors around. 11 times 3 is 33. 10 times 1 is 10. Straighten out this improper fraction. 33 divided by 10 is 3. with 3 left over. So the total up here is 3 3/10. Okay, now we're going to write an expression to match, and then we're going to evaluate. So this is the word form that you will have to also be writing in the next couple of lessons. So pay close attention to the words like sum, and the sum of what, and because that's putting things together. So take the words, make them numbers. That's what it means, write an expression. 1/6 the sum of 16 and 20. I need to get the sum of 16 and 20. Write that first and put parentheses around it. Okay? Because this has to come first. Now, what am I doing with this sum? I'm going to take 1/6 of it. Now, notice I said of. So I know that 1/6 of something means multiply. That's why I'm using the word of, so I can kind of help you along. 1/6 of the sum of 16 and 20. And now we're going to solve. So we've got our expression. PEMDAS says I have to solve what's in parentheses first. So 20 plus 16 is 36. I have to multiply that by the fraction that I'm just going to bring it down. We do a lot of copying. And now I have a fraction of a number, which we did previously. So 1 times 36 over 6. If you remember how to cross cancel, okay, it's really 36 divided by 6 because I can use the commutative property to move that around. And then 1 times 6 over 1 would be 6. Let's do B. Subtract 5 from this. Okay, so I have to get this first before I subtract 5. 1/3 of 23. 1/3 of 23. Notice I put a little dot there. Okay, dots mean multiply is equal to multiplication. So sometimes we can use dots. I think I put that in a previous lesson too. So I have to solve the 1/3 times 23 over 1 before I can take anything away from it. Now the location, the placement of this, very, very important. I have to take 5 away from it. A lot of kids will just see the 5 and they go 5 minus because they said the word subtract. And it's like, no, no, no. We have to take 5 away from this. Remember that in subtraction, the whole comes first. W-H-O-L-E, whole, the whole thing, everything, the whole enchilada, everything you have, that comes first. So let's solve. 1 times 23 and 3 times 1. Now I can straighten this out because basically I have to take 5 away from it, but right now it's an improper fraction. So 3 fits into 23 7 times, if you know your facts. 3 times 7 is 21 and 2/3. Then I can take 5 away because I now have a nice mixed number with a whole number that I can pull from. And since I'm out of room, I'm going to do 7 2/3 minus 5, which gives me 2 2/3, and that's your answer. So circle that. I think I'm going to adjust my little thing here. Okay. So how about C? 3 times as much as, okay, that sounds like 3 times, as much as the sum of this. Notice how they set it up. The sum of this and this. So I need to get the sum of this and this, 3/4 and 2/6. And when I get that sum, first, notice I put the parentheses in, then I can multiply it by 3. Okay? When I get the sum, then I multiply. Now, again, we're adding fractions. You have to have a common denominator. You can't proceed without having a common denominator. This is one where I'm not going to use 24 because I don't want to. And there's a lower one. And if you remember, our strategy would be to line things up and skip count until you notice you have a multiple of that other factor. So 4, 8, 12, 2 is the scale factor for 6, 3 is the scale factor for 4. I can change everything into 12ths very simply. 6 times 2 is 12. 2 times 2 is 4. Use the scale factor on this side only. Don't mess around with this one. 4 times 3 is 12. 3 times 3 is 9. Your equivalent fractions should go right below the ones that you already had. I still haven't added it. I just made equivalent fractions, so copy your procedure that you're going to do next. Just copy it and bring it down. Only do one thing at a time. Don't get overwhelmed. Now add it up. 9 plus 4 is 13. That gives me an improper fraction here, but that's okay. Now for this one, there are a couple, we can take it apart. We can set up 3 over 1. I can show you how to do a whole number times the whole number and then the whole number times the fraction. But for right now, because I can cross cancel, I'm going to rewrite it in a neater way so I can cross things out. 3 and 12 are compatible. So if I was to shift things around, I could have 3 and 12 be simplified into 1/4. 3/12 makes 1/4. When I do that, I end up with 13/4 because 1 times 13 is 13, 1 times 4 is 4. And now I just straighten out my improper fraction. And so 4 goes into 13 3 times, 4, 8, 12, and then 12 to 13 is that 1. And so you should end up with 3 and 1/4. And, sorry, it's super squeezy here, but 3 and 1/4. There go the lights. Somebody is saying, go home, get a life. Okay. Anyway, this is my life, math videos. All right, 2/5 of the product of 5, 6, and 42. A lot of ofs there, so be careful. 2/5 of the product. That means I'm going to multiply this and this. So 5/6 and 42. Let's just put that in a fraction over 1. 42 divided by 1 is 42, so I can do that. Okay, now I have to take 2/5 of that product. Okay, so 2/5 of the product would be a multiplication on the outside and multiplication on the inside. But I must solve what's on the inside first because I have to get the product before I can do the multiplication. This product first. Now 6 and 42 are compatible. 6 times what is 42? If I was to switch these two around, I would get 42/6, which is what? 7. Now I have 5 times 7 over 1, which gives me 35. Now I'm still going to multiply that. This is all done now. Multiply that by 2/5. My next step, 2/5 times 35 over 1, is to simplify this one. If I was going to switch around or use the commutative property, 35/5 would be what? 7 again. Now I have 2 times 7 over 1. So my final answer, 14. I know there's a lot going on in this video. I know it's tough. In fact, I think the second half of this is going to have to be on a separate video. So I'll finish up this page, then I'll run. I'm going to do another video for the second half. That way I won't get cut off. And if you've got this, you don't have to watch anymore. But if you need help with the word problems, just come back on that second one. So 8 copies. Here's that word. I introduced that in a previous video. I said, oh, they're going to use copies. It's like a Xerox machine is what we used to call them when we were young. Copies means multiply. 8 copies of what? The sum of this and this. So I need to get the sum of 4/3. What does that look like? Looks like an improper fraction. And 2 more. Weird. Okay, 2 more what? Just 2. That's what they're doing to you. Not very nice, but yep, that's what it is. So it's 8 times 8 copies of the sum of this, 4/3 and 2 more. First, we have to get the sum. So let's shake out this 4/3. Just rewrite 8 dot. Okay, 4/3 is 3/3 plus 1/3. So it's 1 whole and 1/3. Okay, just do one step at a time. Rewrite your 2. Not going to kill you. Okay, 1 and 1/3 plus 2 is actually 3 1/3. Now I've solved that, and I have to multiply. And this is, again, where we could take the 8 and we could multiply it by 3, and then we could take the 8 and multiply it by 1/3. That's one way. We could turn this into an improper fraction and do 8 over 1 times 10/3, which is another way. There are so many different ways you can do it. I can never decide. I'm like, what's the best way? So anyway, let's do one on one side and one on the other. 8 times 3, we'll do that first, and then we're going to add to that 8 times 1/3. Okay, so this gives me 24, and then this is really 8 over 1 times 1 over 3. Okay, and that would be 8/3 right there that I would add to my 24. So how much is 8/3? 3 goes into 8 2 whole times for 6 with 2 left over. So it's 24 plus 2 and 2/3, 26 and 2/3. Now what if you want to do it the other way and just start with 8 over 1 times and then an improper fraction? 3 times 3 is 9 plus 1 is 10. How will that work out? I don't have anything to cross cancel, so we just straight across multiply, and now you have kind of a big division problem, but you can do that straight long division. 3 goes into 8 2 times, 6, subtract 2, bring down 0, divide 20 divided by 3, 6. 6 times 3 is 18. If you remember your steps, subtract. There's my fraction. So some people want to do it this way. Some people want to do it this way. I think that the tendency is to lean more toward this. We're kind of getting away from this. This is kind of old school. Your parents will probably do it this way. Totally fine. Nothing wrong with it. But this is where they're kind of wanting you to go, so we can do it more like in an algebraic way. Okay. Last one for this video. Click subscribe if these are helpful. I hope they are. That's all I want to do is help you guys out. 4 times as much as 1/3 of 8. 4 times as much as, what do I have to do first? 1/3 of 8. Let's just put that 8 in a fraction so we don't have to write it again. Multiply across and do 4 over 1 times 8 over 3. How did I get all that? I just put 4 in a whole number fraction, like 4 over 1. And then I multiplied 8 times 1, and I multiplied 3 times 1. Now, again, I can't cross cancel here. So if I was to solve this, I would get 32 and solve that and get 3. Now it's a division problem. 32 divided by 3. I know I can get 10 3s into 30 and have 2 left over. So that's the end of this video. Otherwise, it's just going to be too long. Come back again, or hopefully if it's on autoplay, the next one up will be lesson 10, page 2. I'm going to label this one numbers 1 and 2, but when we turn the page, it'll be 3, 4, and hopefully 3, 4, 5 all together. See you in a moment.